I try to make it smaller so that it doesn't take as long. But all right. So I have -8, right? Cut out. All right, we good. All right. So any questions on how that's -8? Or we all know how to do that? So we good? Yeah, just multiply it straight across. All right. All right, let's take a look at another little review question. Help me out with this. I want to simplify this. What do we do? Not separated, not LCD. That's for adding and subtracting. 1/3, good. So very simply, 8 goes into 8 once, 8 goes into 24 3 times, right? Excuse me. So this becomes what? 1x/3y. Very good. Just like that. Questions on that? It doesn't matter. Same thing. Yeah. I mean, but just to use less ink, I guess, just put X. Sorry about that. So we good? Make sense? All right, let's take a look at what we're getting into today. Get ready, get ready, get ready. So we're going to be simplifying expressions using properties of exponents. Yikes. So let's talk about this. So remember that an exponent indicates repeated multiplication of the same quantity. For example, in the expression a to the m power, the exponent m tells us how many times we use the base a as a factor, right? So a to the m is equal to a times a times a m times, right? Go ahead. So we have the two to the third. -2 to the third, right? It would have been like that. Yeah. Oh no, because I want the final number answer. That's why. Yeah. But yeah, that's how you would figure it out though, like that as well, you know? And then over here, for example, we have -9 to the 5th power. So that means -9 times -9 times 5 -9s. Yeah, like that. You know? So we're dealing with exponents. Yay. But real quick though, like let's review some vocabulary with the exponents. Just wanna throw some big words for our Scrabble game later. Right? So exponential notation, right? So I just want to be clear, right? The base, right, is the A, right? The exponent is that superscript number at the top, the little baby number at the top right here. That's the exponent, right? So a to the m power means multiply a m times, right? By itself, right? So a to the m is equal to a times a times a, however m times that is, right? This is read as a to the mth power. In the expression a to the m, the exponent m tells us how many times we use the base a as a factor. Just want to be clear about that. All right. All right. So here's how we're going to use that knowledge real quick. And if you guys need to rewatch this, I totally understand. It's being recorded, so don't worry. So when we combine like terms by adding and subtracting, we need to have the same base with the same exponent. Remember that from last class? Same base with the same exponent. But when we multiply and divide the exponents, right? Excuse me. But when you multiply and divide, the exponents may be different. And sometimes the bases may be different too. So first we'll look at an example. This leads us to the product property, all right? So this is gonna be our first technique that we're gonna go over real quick. Product property. Bam. And make that a little bit bigger. I can rewrite it over. What color do you like? No. Which color do you like? Pick one. Any color? So blue doesn't work. You can't see that? You can see that? You can see that? What color works for you? Tell me. Orange. Let's go with that. So this says 2 factors. This says 3 factors. All right. You have that line. This is 5 factors. Welcome. And we have that. Okay. So let's say that I have x to the second power times x to the third power, right? So now these have the same base, but they have different exponents, right? So what does that mean, right? That means that I'm going to take x times x, is x to the second, right? And then I'm going to multiply that times x to the third, which is x times x times x, right? Notice what my answer is right here. My answer is x to the 5. Right, right, exactly. So that's what I did to that power right there, right? I just added them. That's that secret right there. That's the sauce. All right. Hmm? Not combining like terms, right? Like what I'm doing is you see how there's a 2 right here to the second power, and then there's a 3 right here that's to the third power, right? And then over here down in the answer, this is to the 5th power. Let me erase the box, right? So well, what I'm alluding to, right, is that whenever you're multiplying exponents, you add their powers. Yeah. It's the same base though. They all have the same x, same base. It's just the power that I'm playing with. All right. You add the powers. Yeah. All right, let's take a look. So notice that 5 is the sum of the exponents 2 and 3. We see that x to the second times x to the third is x to the 2 plus 3 power, or x to the 5th, right? Bam. So the base stayed the same and we added the exponents. This leads us to the product property of exponents. So the product property of exponents, the base stayed the same and we added the exponents. All right. That's our first technique right there. But now I know somebody needs to hear it a third time, so I got you. Got you. Hey, how are you? This next one is just for you, right? So this is the product property for exponents, right? If A is a real number and M and N are integers, numbers, right? Then A to the M times A to the N is equal to A to the M plus N power. So to multiply with like bases, you add the exponents, all right? So this is the sauce right here. Damn. And this is also a nice way to remember it too. If you don't want to remember the words, you can remember the formula. Your choice. You know? And the reason why this works is up here. Like when you have the x to the second times x to the third, and you just multiply them together, you're just counting how many you're having, you're increasing it, basically. All right? Down? Gotcha. Yeah. So let me see if y'all get it. Help me out with this. Need y'all do this lesson for me. All right. So for A, right? Oh, nope. Let me get my pen. Let me get my pen. What color you want? Which one? Red. Red? All right. We're going to do red right now. All right. So for A, right? I got y to the 5th power times y to the 6th. What does that become? Y to the 11, right? So we just add the powers together, 5 plus 6, and then that becomes y to the 11. Awesome, awesome, awesome. Let's see, somebody else, pick a color. Green, all right, cool. We got the BCC green coming up, all right? So B, right? I got 2 to the x power times 2 to the 3x power. What does that become? 2 to the 4x? Yeah, you're right. X plus 3x becomes 2 to the 4x. Very good. Questions on that, or we all see that? See that? Good. All right. Exactly. It's 1 plus 3, 4. All right, next color. What we got? Purple. All right, I'm gonna do purple and then I'm gonna do pink next. All right. So for C, I got 2a to the 7 times 3a, right? What does this become? 6. A to the what? 7. No, a to the what? 8, right? 7 plus 1, 6a to the 8th power. Right? Uh-huh. Yeah, so like there's no number there, but you could think of there being a 1 there. So 7 plus 1, 8. Right? Right. So when we multiply the powers, we just add the exponents. No, that's different. That's a whole nother conversation. We get into that though. Yeah. That's what I'm saying. This lesson's about to be real right now. You know? So look, I got d to the 4th power times d to the 5th power, yikes, times d to the 2nd power. What's that? 11? I guess so. Hold on. 4 plus 5 plus 2. That's 6, 10, 11. Yeah. D to the 11. Questions on that? Go ahead. Mhm. Because in the purple one, right, we had coefficients there, right? 2 times 3. They did like right. So with the numbers that are in front, the coefficients, those can multiply to each other. But the base doesn't. The base stays the same. That's why in the B, like 2 is the base number, so that just stays the same. Wait, say that again. Yeah, yeah, yeah. Because it's 2 different numbers, you actually multiply it out, or because because it's 2 different numbers, basically. Yeah. You keep the same base. Yeah, the same base. Yeah. Yeah. So no, 4. Let me do that again. Like this, right? Yeah. So 4 times 4 would give me 16, a to the 8th power. Yeah, that's Because the number is on the outside. Yeah. 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 So for me, the way I'm looking at it, if there's a coefficient, a number in front, that's being multiplied, right? If there's kind of, yeah. So like this number in front, that's definitely gonna get multiplied to give me this other number over here. You know, in the green, I did in the green, no? Oh no, the green doesn't have a number in front though, because the two is the base, right? Like the yeah, yeah, yeah. I mean, if it does have a base, but if it has a coefficient, the coefficient gets multiplied. So let's look. Definition of coefficient and base. I got you. So coefficient is the number that's in front of the base. The base is just whatever the variable is, right? So look, base is this number right here, right? That's the number that the power is being applied to. And the exponent is a superscript number up top. That's the exponent. Right? The base is the number or whatever that the power is being applied to, right? It could be a variable. That's why I had to say whatever. Yeah. Yeah. The power being divided. It's being applied to. Yeah. So, okay. So who is two with a big X, not the X above? Is that what it is? It's two with X. Like two with a big X is like a variable. That's different. Right. Yeah. That's a little bit different. The variable. Kind of. Basically, two A, two has a variable A on. Two B doesn't have variable. That X is basically. It doesn't. The power. Yes, the X is the power. Yeah. And that's why it's being added. You guys try. Hmm? It's good. It looks clear. It looks clear what? Yeah. No, it's not. That's the base. Yeah. B power 9. Nine. Yes. Yeah. Keeping B, no, not adding. Yeah. Adding to power. Mm-hmm. So for letter B, gotcha. You multiply the force. Because it's not the letter. Right. It's the powers you're messing with. Yeah. Mm-hmm. While y'all doing that, done already? That's what's up. Give y'all a few more minutes. Oh my God. Yo, 60 questions. Damn. Yo, that is next level. Have a nice weekend. Nah, that is OD. That is OD. Yeah, D is not. Oh, it's just a period. Something. Yeah. Misspelled that word. Hmm. It's gonna take me like half a class to go. Sorry. Anyway, let's go over this. So for A, right? What's the answer? Very good. Any questions on that? We good? That's it. Just add the powers. Yeah. So b to the 9 times b to the 8 is b to the 9 plus 8 power, which is b to 17. That's it. How about b? So I hear 4 to the 3x. Good. Questions about it, or are we good? Mhm. 16? That's the base. The 4 is the base. Mhm. Yeah. So what about C? What's the answer? 12p6. Now we're talking. Right? 5 plus 1. Right? So P has no power. Yeah. So P by itself with nothing there, there's an imaginary 1 there. So 5 plus 1 is 6. Yeah. Let's go rainbow. D. Very good. Questions? So we all good at adding? All right. Right? Actually, to be honest with you, that is the whole class. Like legit. Like even like if you ask me, oh, what we doing next week? We're gonna learn a new technique. We're gonna add, subtract, multiply, and divide it. Like that's legit the whole class. But some of the stuff that we're learning, like you've been doing it already for homework. Like it's not new. No? So now we will look at an exponent property for division. As before, we try to discover a property by looking at some examples. All right. So I want to divide powers. That's what I'm trying to do right now. All right. So let's take a look at this, right? Make that a little bit bigger. So let's say that I had x to the fifth power divided by x to the second power, right? And I also have x to the second power divided by x to the third. We all know that x to the fifth power is just x times x times x, like 5x's, right? And we know that x to the second is just x times x, right? If I'm dividing, right? If I'm dividing, let me change my color real quick. What's the right word here? Variables, right? And they're the same, right? I can cross out the same terms on the top and the bottom, right? Which is what they did in the next one. So I don't know why I'm doing that, right? This one matches this, and this matches this. Now I have nothing else left on the bottom. So I just have x to the third power as my answer, right? Exactly, right? But what are you subtracting? The exponent, right? I'm looking for something a little bit more specific, though. Right, but what are you subtracting? Mm-hmm. Like, which numbers did you subtract? No, not the base, like the exponent, but what numbers did you subtract in this? We started off here. All right, so you subtracted 2 from 5, right? All right. So I'm looking for something more basic than that, right? So I'm looking for you to say you subtracted the bottom from the top, right? Or top minus bottom, right? That's how you divide exponents. Top minus bottom. Same thing on the other one, right? Let's take a look at this one. So I have x to the second power divided by x to the third power, right? So same thing, right? X to the second, you know, is just x times x over. X to the third is just x times x times x, right? We're dividing it out, right? So this matches on top, matches the bottom, on top matches the bottom. So what am I left with? I'm left with just 1 over x. And that's my answer. That's simple. Didn't it make sense? Why? Just cross it out. Huh? Say it again. You're right. Right? Because x raised to the 2 minus 3 power is x to the negative 1 power, right? But what does x to the negative 1 power become? Right, it becomes 1 over x. That's the sauce. That's the secret. We're going to get to that. Right. What was your question? Yeah. Got you. All right, so let's take a look. Boom. So notice in each case, the bases were the same and we subtracted exponents. We see that x to the fifth power divided by x to the second is x to the 5 minus 2 power, or x to the third, right? We see that x to the second power divided by x to the third power is x to the negative 1, or 1 over x. When the larger exponent was in the numerator, we left with factors in the numerator. When the larger exponent was in the denominator, we were left with factors in the denominator. Notice the number of factors. Notice the numerator of 1. When all the factors in the numerator have been removed, remember, this is really dividing the factors to 1. And so we need a 1 in the numerator. So x divided by x is equal to 1. This leads us to the quotient property of exponents. All right? Quotient property of exponents. So it makes sense? Somebody need to hear it a third time. I got y'all. I got you. So quotient property of exponents, let's take a look what that is, right? So if a is a real number, where a cannot equal 0, and m and n are integers, then a to the m power divided by a to the n power is equal to a to the m minus n power, right? Where m is greater than n. And a to the m divided by a to the n is equal to 1 divided by a to the n minus m, where n is greater than m, right? To be honest with you, all I really care about in this is this one right here. If there was one thing you should remember, it's just this part. The rest of it, you'll figure it out. For example, all right, let's say that I want to do A, right? Let me start with rainbow and work my way back. I want to do A. So I have x to the 9 power over x to the 7 power. That becomes x to the 9 minus 7 power, which becomes x to the what? 2. That's it, right? Let's do B. It's that aqua color right here, right? So I have 3 to the 10 power, yikes, over 3 to the second power. That's going to become what? 3, right, to the 10 minus 2 power, which is 3 to the 8th power, right? And if y'all got calculators, y'all can finish that. I don't know my timetable's that good. All right, let's look at C. So for C, I got B to the 8th power over B to the 12th power. What does that become? Okay, 8 minus 12, which is what? Is it 6? I don't even know. -4, I like that. B to the -4, right? And what does that become? 1 over B to the 4 power, right? Mm-hmm. Anytime you have a negative exponent, you're gonna throw it down in the denominator like that. Okay. Boom. All right. Let's look at, ran out of good colors. Let me see what this one does. Let's see if we can read that one. That's D, right? So I got 7 to the 3rd power over 7 to the 5th power, which becomes 7 to the 3 minus 5, which is exactly 7 to the -2. And then that's going to become 7 to the 2nd. Very good. Now, I happen to know what 7 to the 2nd power is. I know it's 49. Yippee. Questions on that? Hmm? Hmm? That is 7. I prefer the 49. I feel like we could do that. I probably should do it to the 3 to the 8th, but I'm not gonna lie, I don't even know what that is. Let me see if I can do it. 3 times 3 is 9, 27, 81. No, I give up. After I hit 81, I don't even. Matter of fact, I'm gonna just cheat. 3, 3 to the 8th. Oh shoot, that's a crazy number. 6,561. I ran out of fingers and toes on that one. You can leave it as 3 to the 8. Yeah. So no more questions. This makes sense. Go ahead. Mm-hmm. Yeah, the coefficients would divide normally. Yeah. So then that would be in the answer as well. What? Mhm. Yes. Throw it in the denominator and turn it positive. Always. Mhm. I mean, to be honest with you, that's how I do it. Turn it negative, throw it in the denominator. You guys try. If I hear there's rain tomorrow, yeah. On Sunday, it couldn't wait till Thursday. Damn. Dang. You're not even in winter yet, yo. I'm scared. I can only imagine July 4th, though. Yeah. Yeah. I heard it was, I think India had like a record day, like a stupid hot day. Um, 3 days. Yeah. Nah, that's scary when you could do that. I think you do that next. Yeah. There was some place, I think it was during the pandemic, they had like this crazy heat wave and somebody did it. Like legit, like boom. Yeah. Yeah. Like there's some places they heat up their cast iron on the floor. Yeah. Like Arizona. It was I think it was in Arizona. Yeah. But they also had some other thing like say you outside, right? And you just fall on the ground, like you will get like first, second degree burns off of that. Like you can't fall down. Like if you have a puppy, you can't walk your puppy outside. Like some extreme thing. Yeah. Yeah. You know, over in Arizona, I hear it's illegal for you to water your plants because it's like a water shortage over there. So I hear what they do is like people will like grow their plants to a certain level and then they just like spray paint it so it looks green, you know? That's great. Right? I personally like stones. I don't know. I can't. Yeah. Yeah. So I'm not gonna lie. If I have a lawn and then like a car drives on it, I'm mad now. Like you don't see me trying to grow. I recommend the TI-36X Pro. It's a good calculator. Oh, 15. Staples, Amazon, eBay, whatever. 36X Pro. Mhm. I'll show you a picture. Just give me a minute. Huh? Yeah. I mean, you definitely need to get it, man. Like this for your license and everything, you know? But this joint, like, it does a lot. Trying to get like a nice image of it so I can show you. Yeah. Not on me. I use Excel as my calculator. All right, it's not the best image of it, but on Amazon, this is what it looks like. Looks like that. I mean, it's gonna get blurry if I zoom it, but that's it.
Is T3?
TI 36 X Pro. 84 is good if you know how to use it. Yeah. Also, 84 costs mad money. Yeah.
That's what
Ain't it like 150 or something, or 120? Yeah. Yeah. But this, nah, not like this.
No,
Yeah. Oh yeah. That joint is mad money. Yeah. I don't know. This is the better one though.
You said Staples.
Staples got it and stuff. In fact, I'll tell you how you hack Staples now, right? So you go online and you find the calculator, right? Find it for something cheap, right? Like not a just like look at what Staples price is and just find somewhere else that's cheaper, right? You go to Staples and they'll price match it. So they'll give it to you right there on the spot for the price that you can find it cheaper at. Huh? You pay 20 for yours? Yeah. 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 Nah, real talk. I had a student one time. I don't even know how to do this. Like, I'll tell you what she did. I just don't know how to do it. She changed the location on her computer, right? To like something in like out Midwest or something like that. And Walmart out there had it for like $5, right? So she found that, right? Went into Staples, price matched it for $5. You know? Like, the hustle's real. I don't know how she did it.
You could do it without. Maybe you turn off your. Yeah, so that they don't know exactly where you are.
Yeah, but how do you change the location so that it look like you
So
in
that
like?
You go on the website, go to this. Action, like your zip code. Let's say
Right.
you're trying to check out.
Yeah.
Put your zip code anyway.
How do you know the zip code of like Arizona? Yeah. What's
That's
just
my question.
really?
Yeah.
See, I gotta try all this stuff.
I did that for one.
Walmart's a bomb. Yeah. I don't know if Costco got it. Those who got Costco. All I know is that Staples will price match. So if you just find a digital version of it, clip that joint, be like, hey, look what I found. That's it. All right, let's look at A. What's the answer?
Expired.
Very good, right? BMW, good car. All right. What about B? To the 7? 9. Yeah. I don't even know what that is. I'm cheating. That is insane. 6 to the 9th power? Oh my god. Yo, that's like somebody's future bank account after they finish this class. Like, damn. I mean, I'm just gonna write out the answer with the like, what is that? 077, something like that. And then 10. All right. One of y'all should proclaim that. That's y'all future bank account. All right. It's about right. All right. I remember my professor said, like, only making this per year. All right. I would take 6 to the 9th because that's like a little ridiculous right there.
then the last.
Yeah. X to the what?
One over X.
X to the -4, so 1 over X to the 4. That's good. And then D. Very good. This equals 12 to the -15, which is 1 over 12 to the 15. Good. Yeah, you know, I really don't know what that is. That is 12 to the 15. I didn't even know that they had such a number. Oh my God. I'm not even gonna write that. Like that's like when the website just taps out. Like I don't like you bugging. Mhm. Yeah, put the 1 over it, drop it in the denominator, and make it positive. Okay. Because it's 15 minus 30. Remember, top minus bottom. And so the top number is 15, the bottom number is 30. So 15 minus 30. So like that before it becomes like that. But I guess it's appropriate because we're going to talk about this later. So the answer that I got on the computer is 1.5. This is big, like 1.5407. And then you notice how it says E plus 16, right? Here's what that means, right? In case you guys ever get this on a calculator, you wonder what does that mean, right? It means 1.5407 times 10 to the 16 power. That's a huge number. That's what E means. They don't have it's not enough space, when you're typing, because they can only show you a limited number of characters. Yeah. Yeah. Right. So you'll see that on some calculators, right? Like, because they only can show you about like 9 or 10 numbers. So that's why they got to do something to kind of make it smaller, so they can show you more decimals, excuse me. So yeah. So let's talk about the elephant in the room. Boom. A special case, right, of the quotient property is when the exponents of the numerator and the denominator are equal, right? Such an expression like a to the m divided by a to the m, we know x divided by x is equal to 1. So for any x, right, where x is not equal to 0. So since any number divided by itself is 1. So long story short, anytime you have something divided by itself, it's 1. All right. I know it's common sense, but just want to say it out loud, you know. But y'all know I like to elaborate, so.
Oh, yeah, this is how this is subtracted.
Yeah, so it'd be the 0 power, anything to 0 power is 1. So the quotient property for exponents shows us how to simplify a to the m divided by a to the m when m is greater than n, and when n is less than m by subtracting exponents. But what if m is equal to n? We will simplify a to the m over a to the m in 2 ways to lead us to the definition of the zero exponent property. So in general, for a not equal to 0, a to the m divided by a to the m becomes a to the m minus m, as you just said, which is a to the 0 power, right? And anything to the 0 power we know is 1. But also a to the m divided by a to the m, it's the exact same thing. You're crossing out the same thing on the top and the bottom becomes 1.
Why is it not 1 over 8?
Because it's to the 0 power. Yeah.
So it's not -1?
No, not -1, 0. Yeah. It's basically you're dividing by the same thing. That's why.
Yeah.
Yeah.
The zero is going.
Mm-hmm. Yeah. So just to reiterate, I know I like to do that. We see that a to the m over a to the m simplifies to a to the 0 and to 1, right? So a to the 0 power is equal to 1. So any non-zero base raised to the power of 0 equals 1, right? Remember this, right? Any non-zero base raised to the power of 0 equals 1. So we good? Nah, y'all took too long to say yes. Let's look at this a third time. All right. The zero exponent property right here. All right. So if a is a non-zero number, then a to the 0 is equal to 1. If a is a non-zero number, then a to the power of 0 equals 1. Any non-zero number raised to the 0 power is 1. We good now? All right. Huh? It'll be something else. But when it is 0, 1. Mm-hmm. That was definitely a homework question. Why? So when you have anything, like let's say x to the second divided by x to the second, right? You know that it's the same thing dividing out. So you know it's just 1. But when you do the math on it, it becomes x to the 2 minus 2, which is 0 power. That's the reason why it's 1. Yeah. Mm-hmm. So you try. What's the answer? Okay. So I heard that, whoops, I always do that. I forget my pen all the time. So I have a, which is 9 to the 0 power. I heard is 1. Good. And then I heard b, n to the 0 power is what? I'm impressed. I'm not gonna lie. No, that's actually coming in calculus. Stay tuned. They call that indeterminate. That's another vocabulary word. Just to make me feel good, right? What's the answer? Okay. 11 to the 0 power is 1. Good. And I got q to the 0 power is 1. Yep. Mm-hmm. Mm-hmm. Anything to the power 0. All right. Since we understand that, let's look at this. So we're going to use the definition of a negative exponent, right? Which is what we spoke about before. Negative exponent throws its denominator over 1. So we saw that the quotient property of exponents has 2 forms depending on whether the exponent is larger in the numerator or the denominator. What if we just subtract exponents regardless of which is larger? Let's consider x to the second divided by x to the fifth. We subtract the exponents in the denominator from the exponents in the numerator. We see that x to the second divided by x to the fifth is x to the 2 minus 5 power, or x to the negative 3 power. All right. Ooh. Just to reiterate that example, just a little bit. All right. So we can simplify x to the second over x to the fifth by dividing out the common factors, right? They both have an x to the second. So we divide that out, boom, boom, and we're left with 1 over x to the third. right? So that's the reason why. Huh? Go up. You want to see this? Give you a minute to do that while I look at some homework. Yikes. Mm-mm. Nope. Nope. Let's see. Mm-mm. That's not good. Oh my God, it doesn't end. Oh, nope. It's not. Mm, yo. I'm just happy that y'all getting this on the weekend. Damn. That's bananas right there. All right, let's continue. Hmm?
Now, in this case, if you get a negative exponent of five,
Mhm.
you get a negative.
Flip it back to the top. Yeah. So what his question was is like, let's say it was like making this up, right? X to like the negative fourth power, right?
Yeah.
So this becomes what? 1/1 over x to the fourth, right? Keep change flip. 1/1 times x to the 4/1. I should have put a dot here. So that becomes, yeah. I mean, it's the same thing. You're applying keep change flip. Okay. You can just write x to the fourth. I get it. Yeah. That's a little brolic, I know. All right, so let's talk some more. So this implies that x to the negative 3 power is equal to 1 over x to the third. And it leads us to the definition of a negative exponent. If n is an integer and a does not equal 0, then a to the negative n power is equal to 1 over a to the n. Remember this, really important right here. All right, let's now look at what happens to a fraction whose numerator is 1 and whose denominator is an integer raised to a negative exponent. All right. So this is actually your question, like Alex. So boom, right? A little bit more generalized though. So if I have 1 over a to the negative n power, right? Use the definition of a negative exponent, a to the negative n is equal to 1 over a to the n. So that becomes 1 over a to the n, right? Keep, change, flip becomes 1 times a to the n over 1, which is just a to the n. Right. Nah, somebody don't get it in the back. I know, I see the look on the face. I got you. So this implies that 1 over a to the negative n is equal to a to the n, and is another form of the definition of properties of negative exponents. All right? Nah, somebody else don't get it. This is somebody watching the recording right now that doesn't get it, so I got you right now. Right? Let's talk about properties of negative exponents. So if n is an integer and a does not equal 0, then a to the negative n is equal to 1 over a to the n, or 1 over a to the negative n is equal to a to the n. All right? Third time's a charm. But just to explain it a little bit more, real quick. Just for those that fell asleep and just woke up, I got you. All right. The negative exponent tells us we can rewrite the expression by taking the reciprocal of the base and then changing the sign of the exponent. Any expression that has negative exponents is not considered to be in simplest form. We will use the definition of a negative exponent and other properties of exponents to write the expression with only positive exponents. So for example, if after simplifying an expression, we end up with the expression x to the negative 3 power, we will take one more step and write 1 over x to the third. The answer is considered to be in the simplest form when it has only positive exponents. All right? Let me highlight that though. The answer is considered in simplest form when it has only positive exponents, right? Long story short right here, right? It is illegal to have negative exponents, period, right? If you have an answer, blah, 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 to the negative whatever power, that's wrong, right? We have to have positive exponents. And how do we make it positive? Drop it into the denominator, make it positive. Over 1. Yes, you can. I seen it happen. Man. Right on Fordham, too. And make it positive. So Theo, try. What's the answer to A? See, I stay forgetting my pen all the time. All right, so we got A. This is 1 over x to the 5th power. Good. How about B? So 1 over 10 to the 3rd power. Good. All right, don't tell me. I think that's like what? 1,000? I think it is. I don't know. Yeah. I feel like that's this year's bank rate. That's how much you get in your savings account. Just sad. So, well, nah, that's not even, that's a penny if you have like $1,000. No, that's so sad. Anyway, so I have 1 over y to the negative 4 power. What does that become?
Why?
Mm-hmm. 1 over y to the 4th, which is, what's the answer? Y to the 4th power. Very good. All right, this is the hard one right here. This is the hard one right here. Y'all might need to work together on this one. This is D. This is 1 over 3 to the negative 2 power. What does that become? Three to the 2, which is 9. We good? Exactly. Awesome. Mm-hmm. Go ahead. No, keep change flip. That's how. All right. So this is going to become what? 1 over 3 to the 2nd. Right? And then we do keep change flip. So this becomes 1 over 1 times 3 to the 2nd over 1. Right? And then that just becomes 3 to the 2nd, which is 9. Like that. Nah. It was 90, honestly, and I like cut it off. That was the weekend homework. So but like I said, there's tutoring, slash there's the calculator. We'll make it happen. Y'all got so much practice for this. Y'all better not get this wrong. Some people. Y'all is like the top. As long as y'all finish the homework by Wednesday, we good.
Next question.
Yeah. Hmm? What with the homework? Gotcha. You over that. Like you enter it and what happens? The answer?
Yeah.
So and it doesn't go through? Oh, like with the keyboard, you mean? So less than is shift and then the side arrow, and greater than is shift and then the right the. Oh, so it'd be like less than and then the equal sign, and then greater than and then the equal sign. Yeah, yeah. I didn't have it. Exponent, bring it up. Let me see. Remember also like there's tutoring online every day. So yeah. So tomorrow there's tutoring in person, right? But that's from 12 to 6. And then Saturday and Sunday is tutoring online from 12 to 6. So if you guys want to come on, you know, I'll be there on Saturday. So you go to WC online, right? And then you just make an appointment there. If you've never been there before, you have to like create an account first time, but then after that, you can just log in and you know. All right, we can go over that at the end of class. I got you. It's in the announcements, but we'll go over it at the end of the class. I got you. Like the last announcement with the recording had it in it, but I'll make another one. So I got you. So let's look at A. I got Z to the -3 power. What's that? Mhm. 1 over Z to the third. I got B. What's that? All right. It's 10 million. Nice. Goals, goals in the future. So what is C? Nice. Very good. P to the 8th power. And then what is D? So 4 to the 3rd power, right? Could I get that? Wait, 16, 64. Yeah. All right. Questions on this? On the P one? I could do that. I could do 1 over P to the 8th power like that. And then, but remember, you have to do keep, change, flip. So this becomes 1 over 1 times P to the 8 over 1. And then you just multiply straight across, you get P to the 8. So we good? Awesome.
Stay across, you mean like straight across or like?
Straight across here.
numerator to block it?
No, straight across. The numerator to denominator thing, that crisscross that you're talking about, is only when there's an equal sign. So suppose now we have a fraction raised to a negative exponent. Let's use our definition of negative exponents, to lead us to the new property, right? Brand new property. Dropping. All right, so watch this now. All right, so now I got 3 over 4 raised to the -2 power, right? So I got a fraction raised to a negative exponent. Yikes. Right? So we already know, right? Negative exponent, I'm just gonna do 1 over 3 to the 4 to the 2nd power, right? And then whenever you raise a fraction to a power, each one, the numerator and denominator gets that power, so it becomes 1 over 9 over 16. And then keep, change, flip. Final answer is 16 over 9. All right? So, but we know that 16 over 9 is, the parentheses is 4 over 3 squared. This tells us that when we have 3 over 4 to the -2 power, that equals 4 over 3 to the 2nd power. But I don't know if you can see a pattern here. You see that? We just proved that these are equal. So what happens? Tell me. What do you see happens when you have a negative power? Right. Right. The fraction flips. Right? That's the trick. And you take away the negative. Right. If it's negative power. So To get from the original fraction raised to a negative exponent to the final result, we took the reciprocal of the base, the fraction, and changed the sign of the exponent. This leads us to the quotient to the negative power property, all right? New vocabulary. Let's take a look at that again real quick. So you have the quotient to a negative power property right here. Whoops. That's good. So if A and B are real numbers where A cannot equal 0 and B cannot equal 0, and N is an integer, then A over B raised to the negative N power is equal to B over A raised to the positive N power. See that? Yeah. So flip it and change the sign from negative to positive. I mean, apply the powers onto it and answer it after that, yeah. Let's try it out real quick. All right, walk me through A.
So it's, 7,
Wait, hold on. Forgot my pen. All right.
parentheses, 7, 5,
Mm-hmm.
2, power.
Good. Which we know is, yep, 49 over 25.
Which is 7, 7, 5 times 7, 5.
Well, 7 squared over 5 squared. Right? Yeah. So whenever we have a fraction and we have the powers, it gets applied to everyone individually. So that's how that works. How about B? What's the answer? You're like, this would be the final answer right here. Negative. Yep. Y over X to the third power. So what's my answer? Negative Y to the third. X to the third. Good. I'll take it. No. No. Why didn't I change the negative? There's a reason why I didn't. Why didn't I change the negative? Math. If it was a square, would I have changed a negative? Mhm. Yeah. So if it was square, would I have put a negative? No, right? Because a negative times a negative is positive. But to the third power, a negative times a negative times a negative, that's negative. So it stays there. Mhm. Yeah. Good observation, though.
So it's not because it's in parentheses, that's separate.
It's because it's in the parentheses. Yeah. That's right, yeah. Mm-hmm. Oh, that's the answer. Like somebody had asked earlier. Yeah. You could, but I'll accept it like that. You guys try. Remember that the videos are on YouTube in case you want to rewatch to do your homework. Y'all can call each other and ask questions.
So who is on that, website we have to
Web
choose,
work.
right?
Yeah, that one. Yeah, first name, last name, username, and password. Remember, I don't care how many times you do the question, just get it right.
Do you see how many times you do it?
I don't care what. mean, if you try a question 20 times until you get it right, I'm cool. Some people do that. I'm cool. I'm not stressing. Yeah. All I care about is that you got 100 at the end of it. So this is 3. August 1st. Yeah,
So we do it.
that'd be
So we
nice.
do the next-
Yeah. So Thursday exam. Huh? You don't want this on it? Why?
So. Everything else is fine. This stuff,
Promise you, it's not so bad. This is easy. When I finish the lesson, I'm gonna show you like a super sheet with all of the formulas, and it'll be like, all right.
then within.
Yeah, you do. You use the division one when you're dividing, you use the multiplication one when you're multiplying, addition one when you're adding, subtraction one when you're
Even that
subtracting.
last. Why?
Mm. Gotcha. I'm not putting that on test. That is brolic. All right, let's take a look. So I got A. Yeah, I got my pen. So this is 2/3 raised to the -4. What's the answer? I'll take it. 81/16. All right, what's B? Very good. Questions on that?
So, yeah, I don't know, I guess 60 those.
Got you. So flip the denominator, excuse me, flip the base, right? And then to the +4, and that becomes 3⁴ over 2⁴, like that. So 3 and 3 is 9, 27, 81, and then
So
2
you
and 2,
flip the
8.
change to negative to positive.
Right. Mhm. Mhm. All right. That being said, now that we have negative exponents, right, we will use the product property with expressions that have negative exponents. Let's take a look. Let's just jump in and take a look. Here's an example of what I'm talking about. All right. We'll go rainbow for this. A. Somebody walk me through it. I have z to the -5 power times z to the -3 power. What am I going to do? Add. Very good. So this becomes z to -5 plus -3, which becomes z to the, right, -8 power. What do I do after that? Exactly. 1 over z to the 8. That was brilliant, right? That's what your homework's going to look like. Let's look at B. I have m to the 4th power times n to the -3 power times m to the -5th power times n to the -2 power. What's the answer? Mm-hmm. So m to the 4 plus -5 power, right? Which is about -1, and n to the -3 plus -2 power. So m to the -1 and n to the, what is it? N to the -5, right? Okay, got you, got you. And what's next? M N to the fifth power, right? Questions on that?
They don't multiply across, just add.
Just add them. Yeah. All right, how about C? This is where it gets interesting. So I got 2x to the negative 6, y to the eighth power times negative 5, x to the fifth, y to the negative 3 power. What do we think? I'll give you a hint. Numbers with numbers, variables with variables.
So,
Negative 3. So negative 10. Yeah. Uh-huh. So numbers first, and then variables. And then it's going to be x to the what? Negative 1, good. And then y to the 5, good. What's next after that? Mm. Mm. Okay, I'll take that. I'll take that. What I was looking for was negative 10 y to the fifth over x. Right? Because x becomes 1 over x. I was skipping a lot of steps in that question. Is there any questions? Okay. Yeah. Go ahead. Negative 10 is 2 times negative 5. It's negative 10. Y to the, oh, yeah, so because it's negative, right? It's illegal to have negative powers.
Okay.
Uh-huh. Right. If it's negative power, if it's a negative power. And then, yeah, this is how I got this answer here. All right, 2 times negative 5, negative 10, x to the negative 6 plus 5, that's x to the negative 1, 8 plus negative 3, that's y to the fifth. But it's illegal to have negative exponents, so throw the x into the denominator, right? The negative 10 and the y to the fifth, imagine that that's already in the numerator. No? And that's it. Right. That'd be the whole number, the whole answer, excuse me. In the computer? Sure, I'll show you. So I'm assuming that I have the negative 10 y to the fifth over x, right? So this one I would enter in as open parentheses, negative 10 y raised to the fifth power, close parentheses, divided by x, like that. Some of the questions might have like a separate thing, like, oh, what's the numerator, what's the denominator? So the numerator is a negative 10 y to the fifth power, and the denominator is just the x by itself. Sure. Sure. Yeah. I'm not even gonna lie. Like half of this, I don't even remember.
So you gotta study before class.
Nah, like There's like one or two things I remember, and from that I could answer all the questions. Mhm. You'd be surprised how little math I remember. Yeah, like some basic stuff, you know. I didn't even know this had a name before this class, you know. I just know to do it. Numbers with numbers, variables with variables. That's it. When I'm multiplying, I'm adding the powers, right? Or I'm multiplying regular, the way I know how. When I'm dividing, right, I'm dividing the numbers in front and I'm subtracting the powers. That's all I remember. All this other fancy stuff, I'm learning with y'all. This one? This was B right here, the n squared over m squared. Got you. Bless you. Oh Lord, hold on. All right, that being said, you guys try.
How did you get,
Hmm?
how did you get the
N squared over m squared. That was the previous question? Yeah, so what's happening in that question, right? You you're flipping the fraction in the base, right? So instead of like m over n, it's becoming n over m, right? And then you're taking the negative power and you're making it positive. And then you apply that power to the numerator and the denominator individually as a variable. Yeah.
So it's the same as,
Yeah. Mhm. It would be that answer. Put like this, right? If it's confusing, right? Go back to what you know, right? You know that whenever you have a negative exponent, it's going to be one over that. Keep, change, flip.
yeah, I
Yeah.
understand, that's why I'm like.
So use it. Forget the little trick. Use what you know, right? Anytime you have a negative exponent, one over that. Go ahead. The negative 10 y to the fifth over x. That one. Yeah.
Negative power.
Think of it as one over positive m divided by n squared, and then keep, change, flip. Then you'll get back to the same answer I got. That's B of the previous. Yeah. So basically, like this is just a trick, right? For me, I don't even use that trick. Right? I just remember it as negative exponent one over. I just keep, change, flip. All right, let's take a look. So I got z to the negative 4 times z to the negative 5. What is that? Negative 9, which becomes very good. That's multiplication. This is for addition. All right, because remember, this becomes, hold on. The dot means multiplication, yeah, but when you multiply exponents, it becomes z to the negative 4 plus negative 5 power. Yeah, that's how that comes in. That's wrong. It's illegal to have negative exponents. So B, right? I have P to the 6, Q to the negative 2 times P to the negative 9 times Q to the negative 1 power. Yikes. How do I do this? Let's see. So I have P to the 6 plus negative 9 and Q to the negative 2 plus negative 1. So P to the negative 3, right? I agree. And Q to the negative 3. So what does that become? Like over P cubed, Q cubed. Okay. It's not bad. I will take that. Genta. How about C? So what do I have? I have 3 u to the negative 5 v to the 7 times negative 4 u to the 4 v. I'm working on it to the negative 2 power. I keep missing this. All right. So I have negative 12, right? U to the what? Not to the 1, U to the negative 1, right? And then V to the 5. Very good. So negative 12 V to the 5th over U. Yep. Questions on that? The 12, yeah. Because that's the coefficient negative. Any questions on that? You good? Go ahead. It's the 12. That's the exponent. Oh, wait, no, excuse me. Say it again. The exponent for you, it's a 1. It's a positive 1 that's there. Yeah, I just didn't feel like writing it, but you have that option. Yeah, it's there. Yeah. Isn't like an invisible 1 right there? But wait, there's more. I feel you. So now let's look at an exponential expression that contains a power raised to a power. There's a whole nother game right now. So see, so see if you can discover a general property. What does this mean? So I have x squared raised to the 3rd power. So we know that that means x to the 2nd times x to the 2nd times x to the 2nd, right? That. So we know that that means what? X times x times x times x times x times x. Count them. How many we have here? We have 6, right? So what does that mean, right? Notice the 6 is the product of the exponents, right? So 2 and 3. So we see that x to the 2nd raised to the 3rd power is x to the second times 3 or x to the 6, right? So we multiply the exponents. That leads us to the power property of exponents. So power property of exponents, what do? Multiply the exponents. That's the sauce right there. All right. All right. Got you. I got you. So the power property for exponents, right? If a is a real number and m and n are integers, then a to the m raised to the n power is equal to a to the m times n power. So to raise a power to a power, you multiply the exponents, right? That's the sauce right there. To raise a power to a power, you multiply the exponents. And see, little things like this is one that I remember, right? Do I remember every single thing? No. Go ahead. Yes. Yes. That's exactly it. And that what you said right there, that's all I remember. All the other stuff I don't remember. A power raised to a power. Yeah. So an exponent raised to another exponent. That's what that is. Yeah. Yeah. Let me see. It's algebra. The people in the Middle East. Yeah. Yeah. It gets easier though. I didn't see that. Really. I mean, send it to me. I'll gladly watch it and tell you.
Well, wait. Our guy who did the worksheet. Yeah. Okay, my dad. He said, we had to. Yeah.
Man, wait till y'all see American math, yo. That joint is crazy. Yeah. American math, yeah.
So what is this, on American?
This is algebra. This is like Middle East over there. Like computer science. That's American math. You'll see it. I did math and computer science. Yeah. But I lean more towards the math than anything. It was easier. So okay, let's look at this, right? And make sure I got my pen. I remember this time. All right. So I got y to the 5th power raised to the 9th power. What's the answer? 5 times 9, good, which is y to the 45. Very good. All right, let's try B. Oh, B looks hard. B looks hard. Let me see. So we got 4 to the 4th power raised to the 7th power, which becomes what? To the 28th power. I ain't even gonna hold you. I don't know what that is. Hold up. I'm gonna cheat. What is that? Nope, not writing that down. That's too much. All right, let's try C. To the what? 15? Why, how'd you get 15? That's what I want you to do.
So,
3 times 5? No. 3 times 6, right? So 18, right? Times y to the what? 20, good. And then this becomes y to the
Oh, yeah,
38, very good. You add it, very good.
I think she was trying.
Yeah.
Like inside the front.
Got you.
We can't do that, right?
You can with the whole numbers.
Oh,
Yeah. Like with the 4, you could have said 4 to the 4th power, like actually answer that and then raise it to the 7th, you know? But that's not our lesson. So, all right. You seem to be picking this up. I got it. All right, so let me see y'all try this next one. A little bit harder, got A's and B's. All right, that's what everybody's gonna get in here, right? A's and B's? All right, all A's, I'm down for that. Yo, stay back after real quick. I want to talk to you about something. Yeah, I can't believe how fast time flies. Oh my gosh. Y'all know I still didn't even finish. I got a lot more. So we leaving out of here like at 11 o'clock tonight, all right? Nobody got work tomorrow, right? All right, let's go over this. So, yeesh. I got B to the 7th power raised to the 5th power. What's that? B to the 35th, good. How about B? I got 5 to the 4th power raised to the 3rd power. That becomes what? 5 to the, whoops, hold on. I just wrote this wrong. Yes, you're right. 5 to the 12th. And C, oh Lord. So I heard 48. Yep, that's good. Hmm. So let's look at that. We have a to the 4 to the 5th power times a to the 7 to the 4th power, right? That's gonna become what? A to the 4 times 5 plus 7 times 4, which you're right, that's gonna be a to the 20 plus, what's that, 28, right? And then 48. Right? Any questions? No? All right. Let's go on to our next lesson. All right. Well, yeah, we doing OT today, man. We gonna leave at 11 o'clock tonight. Right. Nah, we good. Y'all can come sign an attendance.
Excited.
Yeah. Real talk, I got a lot more left to teach. Y'all probably can't finish tonight's homework, which is okay. Just start it, do what you can. All right. And then we'll finish that all on Monday and Tuesday night.
See you.
I see you. Is everybody done copying? Can I stop sharing? Awesome.